Hi friends, in this video we are going to discuss about EMF equation. Which is very important. They will ask you questions on EMF equation. So tell me, generally EMF E is equals to formula d phi by dt. This is the magnitude actually. So for P poles, average flux is equals to d phi, that is equals to p phi, and to complete one revolution, time dt is equals to, can you tell me, n revolutions per minute, nothing but n revolutions for 60 seconds, nothing but one revolution for how many seconds? For one revolution is 60 out of n. This is generally. Now E average per conductor is equals to d phi by dt, nothing but p phi upon 60 by n, that is nothing but p n phi out of 60. This is generally E average per conductor. Sir, but generally EMF equation is phi Zn by 60 and P by A, right? But you are not getting that one. Is it wrong? No, this is also correct answer. But when they asked you E average per conductor, for example, I want total E average. E average is equals to number of conductors this side. So phi Zn of 60 into P. Oh, this is E average. Sir, what about phi Z by 60 P by A? Where is that? So let's see. E average per parallel path. What is that? E average per parallel path is equals to phi Zn by 60 and P by A. This is actually our generated EMF in our DC generator. Up to this is also E average per conductor of synchronous machine and E average per conductor of DC machine. For both the answer is same. And then after we are changing for E average per parallel path. This is generally the generated EMF. So finally, what is our generated EMF EG? EG is equals to phi Zn by 60 P by A. Where what is phi? Can you tell me? The phi is the average flux per pole. Yes or no? For P poles, P times of phi. Nothing but one pole phi. What is Z? Z is the total number of conductors. You should remember this. And A is the number of parallel paths, and you know that A is equals to P for lap winding, A is equals to 2 for wave winding. We know all these words already, but just a clarity. Here N is the speed in RPM. You know that P is the number of poles. You know that. So we know finally E average per parallel path, but they will give you E average per ton. Then how we can get our EMF? If they given E average per ton, then multiplied with the number of tons by number of parallel paths. Then what we get? Tons get cancelled, then E average per parallel path will come. That's very simple. If they given E average per conductor, but I want E average per parallel path, how we can get? Very simple. If they given E average per conductor, then it's very simple. Number of conductors by number of parallel paths. Then what we get, these two gets cancelled out, then you can get E average per parallel paths. Like that you can find the generated EMF. Generated EMF is nothing but E average per parallel path. You should remember that point. So this is generally very simple question, that is EMF equation. You must and do this. Already many times asked in many competitive examination. Even in GATE also they asked nearly 3 to 4 times on EMF equation. Very easy, right? Right. Next one. Let's see here. For example, they will ask you a question. What is EMF equation for lap winding? Let's draw. What is EMF equation for lap winding? Very simple. The EMF equation of lap winding is equals to phi Zn by 60 and P by A. A is equals to P. So the answer is phi Zn by 60 for lap winding. What is EMF equation for wave winding? For wave winding is equals to phi Zn by 60 P by A. A is equals to 2. This is for wave winding. For how many number of poles? Lap winding EMF is equals to wave winding EMF. Very simple. If P is equals to 2, 2 gets cancelled, then EMF in lap winding is equals to EMF in wave winding for 2 number of poles. For example, if P is equals to 4, then EMF in wave winding is equals to 2 2s are 2 2s are. So 2 times of wave winding, 2 times of lap winding. EMF in wave winding is equals to nothing but, in general case, EMF in lap winding is greater than, EMF in wave winding is greater than lap winding, and the current in wave winding is less than lap winding. Actually, this is already you know. High voltage, low current, low voltage, high current. I explained you already. Clear. Now next, what is next? Can you tell me what is next? What I have to do here? Now let's see. For example, the power in wave winding is nothing but EW and IW. The power in lap winding is nothing but EL and IL. This is generally. Is it okay? So generally the power is constant in lap winding and wave winding, but voltage and currents are changes. Now what is the answer? EW IW is equals to EL IL. So the EMF in wave winding to the EMF in lap winding is equals to current in lap winding to the current in wave winding is equals to, in generally, the number of parallel paths in lap winding by number of parallel paths in wave winding, because here number of current is more and parallel paths are more. Current is less, parallel paths are less. You should remember this relation. This relation is important. Now, very important relations are that the EMF in wave winding to the EMF in lap winding is equals to the number of parallel paths in lap winding to the number of parallel paths in wave winding. This is very important. They will ask you a question. 8-pole DC generator, EMF in lap winding to the EMF in wave winding is equals to how much? What is the ratio of lap winding to the wave winding EMF? It's very simple. Lap winding to the wave winding, don't confuse lap winding to the wave winding. So AW upon AL. AW, number of parallel paths in wave winding 2, number of parallel paths in lap winding is equals to 8, because number of parallel paths in lap winding is equals to number of poles. So the EMF in lap winding to the EMF in wave winding is equals to 1:4. Nothing but the EMF in wave winding is equals to 4 times of the EMF in lap winding, because the voltage is more in wave winding compared to lap winding 4 times. So, like the silly questions they are asking in some competitive examination. You should remember these all points. Are you okay? Getting or not? My point. Alright, sir. Up to this, you know very well everything. Now they will ask you question. What is the, let's see, for example, a DC generator, for example, 4-pole DC generator having armature resistance of 16 ohms, which is connected in lap winding. If it is reconnected as a wave winding, then what is armature resistance? This is the question. Very simple. Now I want the relation between armature resistance and other. Armature resistance of lap winding 16 ohms. What is the armature resistance of wave winding? Can you tell me what is this? So very simple. Here I said you already, the power in lap winding is equals to power in wave winding. Nothing but I square R is equals to I square R. What I want? The armature resistance in wave winding to the armature resistance in lap winding is equals to IL upon IW whole square. Nothing but the AL upon AW whole square. This is very simple question. So tell me what is answer here? RAW by RAL, the given 16 is equals to AL, number of parallel paths in lap winding. Number of parallel paths in lap winding is number of poles. By wave winding is 2 whole square. 2 ones are 2 twos are 2 square 4. 16 fours are 64 ohms. So in wave winding, the armature resistance is 16 ohms. Sir, is it correct? Is it possible? Do you have any doubt? Let's check. Let's check it and clarify. Is it correct or not? 4-pole machine, lap connected. Nothing but how many parallel paths are there in 4-pole machine? That's why number of parallel paths is equals to number of poles, that is equals to 4. So 4 poles, 4 parallel paths, and they given the total armature resistance is 16 ohms. If this is 16 ohms, can you tell me what is the armature resistance in each parallel path? Generally, it may be 64 ohms, 64 ohms, 64 ohms, 64 ohms. So 64 by 4, 16 ohms. Is it clear? But this is reconnected as a wave winding. This is actually lap winding. This is reconnected as a wave winding. Now tell me, in wave winding we have only 2 parallel paths. Like this. I want this armature resistance. This equivalent resistance. This is 2 parallel paths, but we have to include total conductors. Nothing but this is 64, this is 64. This is 64, this is 64. Nothing but 64 plus 64. 128 in parallel with 128. What is the answer? 128 in parallel with 128. The answer is 64 ohms only. Because when 2 are in parallel, by 2 will come. So this is 64 ohms is our answer. Let's see here also. The answer is 64 ohms. I got it. Yes or no? So like this they will ask you questions. Let's do another question. A 6-pole DC generator having armature resistance of 6 ohms, for example, in lap winding. What is the armature resistance in wave winding? Like that they will ask you question. Can you tell me what is formula? Simply I wrote this. Can you tell me what is the formula? Armature resistance in wave winding to the lap winding is equals to, do you have an idea? So tell me. Very good. AL upon AW whole square. Nothing but AL is the 6 and AW is the 2 whole square. So RAW is equals to RAL multiplied with 9. So 54 ohms is your answer. Like that. Let's take the, how many parallel paths here I have to take? 6 parallel paths. 6 parallel paths like this. So what is total value? 6 ohms. Nothing but each of 36. Each of 36. But here this is converted into wave winding for only 2 parallel paths. Like this. Nothing but here I have to use all the conductors. Nothing but 36, 36, 36, 36, 36, 36. What is that? 90 plus 18. 108. Parallel with 108. The answer is 54. That's very simple question. Like that, they will ask you questions on the EMF equation. If they ask you question on this basic EMF equation, you can do the answer easily. 5Z by 60 P by A. Everything they will give you. Sometimes they will ask you question. This is wave connected and parallel paths. Number of conductors per parallel path is 100. Then what you have to substitute here? That is wave connected. Parallel paths. Conductors are 100, but in generally in wave winding we have 2 parallel paths. For one parallel path, 100 conductors. For 2 parallel paths, how many conductors? 200 conductors. So you have to substitute here 200 conductors. Don't confuse. We have to take a total number of conductors. Generally, blindly some people doing that. Generally, what is the given data? We have to substitute. Not thinking, right? So when they given wave winding, we have 2 parallel paths. 2 parallel paths. Each parallel path number of conductors 100. So for 2 parallel paths 200, you have to substitute and get the answer. So this is generally the EMF equation questions. Are you clear? Is it okay? Right? Let's see an example on EMF equation many times asked in competitive exams. For example, 8-pole DC generator having simplex wave winding, like that they given, which rotating at 250 rpm and flux per pole is 0.06 Webers. They given like that. 8-pole DC generator, simplex wave winding, 250 rpm and flux per pole they given. So then they are asking what is generated EMF when the machine having 32 coils, 6 tons each coil. 6 tons each, 32 coils, 6 tons each. This is my question. This is a multi-ton coil. Totally the coils are 32 and tons per each coil. Tons per each coil is 6. So total tons is equals to, tons are 6 for each coil. So what is the values are here? 180 and plus 12, 192. 192 number of tons. And we know number of conductors is equals to 2 times of tons, because every ton having 2 conductors. So what is answer? 2 times of tons. 192 is the total number of conductors is equals to 384. You have to calculate like this, then only you can get the answer. Actually the question is just how do you find out the number of conductors is the main thing. Yes or no? For example, this is ton. This ton having 2 conductors. What is the formula? Z is equals to 2TR, T is equal to 2Z. How many tons are there here? Only 1 ton. So if T is equals to 1, number of conductors is equals to 2. Like that. Z is equals to 2T is correct answer, not TZ. Right. So I got number of conductors. What is EMF equation? EZ is equals to 5Zn of 60 and P out of A. So here Flux per pole they given 0.06. Number of conductors also they given 384 indirectly. Speed they given 250 rpm. Number of poles they given 8. Number of parallel paths of wave winding 2. Then substitute all the values, you can get the answer. Substitute here. The generated EMF Eg is equals to 5 is nothing but 0.06. 0.06 nothing but just write like this. You can get the answer clearly. So 6 by 100. Number of conductors Z 384 and speed 250 rpm by 60. Number of poles 8. Number of parallel paths 2. This is the answer actually. See here, 6 ones are 6 tens are, right? 2 ones are 2 fours are, right? 0 0, 4 ones are 4 25s are, 25 25. So what is the generated EMF? 384 volts. What is the generated EMF? 384 volts. See, I said you already. Actually, the question is that how you are calculating the number of conductors. This is the question actually. Based on that, they will ask you question. So they asked that 384 volts is our answer. I am not cancelling this one. So actually, by practice, you can get how to solve, how to calculate. We can get the answer directly. Yes or no? If you calculating this one, you are wasting time just by within fraction of seconds. The calculations are very important in the problems. Of course, you know the formula way of procedure, but if you weaken mathematics, this is not mathematics. This is basic mathematics. Just this is will do by even the second standard people also. Yes or no? So this is generally the way of questioning on EMF equation differently. How you have to calculate. They given 32 coils, 6 tons each. Nothing but each coil having 6 tons. So finally the tons are 192. But we want the number of conductors. Of course in the option 192 also is there. 384 also is there. Another one, another 86 also is there. Whatever you done, what you get the answer is there in your options. Is it okay? Okay, right? So this is simply about the example on EMF equation, which is very important. Like these questions, they will ask you in your competitive examination. Right? Thank you.